Okay, this video is on circle theorems. This first question says DAE is a tangent to the circle. Write down the size of the angle ABC. So first of all, the angle we're looking for is here, ABC. Now this is an alternate segment theorem question. You probably haven't learned your alternate segment theorem looking quite like this. Most likely you've learned it where you've got your circle. That's a circle, believe it or not. You've got your circle. And then you've got your tangent horizontally, and then your triangle in here. And what you would have learned was that this angle in here, from your tangent round to that chord, that's angle A. Then this will also be angle A. So what you should do is sort of rotate this thing round. So if you rotated that round, so physically rotate your page round until it sort of looks the way that we want it. So if you rotate it around this way, you're going to have something like this, and that would then be your angle A, and that would be your angle A in here, and you can see how that matches up. So in your diagram, that was 61, and that was your A, so that is also, and that's the angle we want, and that's also A, so your 61 is equal to your angle ABC. So the angle ABC is just equal to 61 by the alternate segment theorem. So that's where that comes from. So again, just to go through, very common. This is how you've learned this thing. You've learned it like this, but rotate your page in so it looks the way that it is on the page, and it just it makes life so much easier for you. Okay, this next one. This is what we've got. I have no idea. It says here in the diagram, O is the center of a circle. AOC is a straight line. BAO is 24 degrees, and the angle ADO is 42. Find the size of the angle CAD. So CAD, first of all, CAD is this angle in here. That whole thing, sorry, that's not right at all. CAD is going to be this wee small angle in here. So we can do this very easily then. If you mark on any lengths that are the same, OD is a radius, OA is also a radius, so then this angle is going to be the same as this angle in here. So I'm just going to mark it in. This is also going to be 42 degrees. So it's also going to be 42 degrees for CAD. CAD is going to be 42 degrees. So their isosceles, because it creates an isosceles triangle, then that angle is going to be the same as that angle. Okay, what's next? It says find the size of the angle ABC. Where is ACB? Sorry, ACB is in here. Right, if we look at this triangle here, this is a triangle which is made up of a diameter and then a line out to your circumference. So this angle in here, ADC, is going to be 90 degrees because that's the angle on a diameter. So it's going to be angle and circumference coming from a diameter is going to be 90 degrees. So you can work out your, I'll just do it here, ACD is going to be equal to 180 minus that 90 and minus that 42, which we worked out for the previous part of the question. So 180 minus 90 minus 42, 180 minus 90 is 90, and then minus another 42 is going to be 50. It's going to be 48 degrees. And there we have it. So ACD is 48 degrees. Right, what is next? BCD. Where's BCD? BCD is this whole angle here. So B to C to D is this whole angle here. I'll get rid of my yellow highlights here so we can see then. BCD then is, if you look at this, you have got what's called a cyclic quadrilateral. So four sides of, four vertices, I should say, the four corners of a quadrilateral are on the edges of the circle. So it's a cyclic quadrilateral. So that means opposite angles in a cyclic quadrilateral are supplementary, which means together they add up to 180 degrees. So BCD is equal to 180 minus its opposite angle, and its opposite angle is this whole thing here. So it's 24 plus the 42, which is going to be 66. And then if you do that 180 minus 60 would be 120, minus another 6 is 114 degrees. Just check my calculations here. I'm doing this in my head. And that is it. So that's BCD. Okay, last question then. It says AOB is a straight line, and B and C are points in the circumference of a circle, centre O, and AC is a tangent to the circle. Work out the size of the angle Y. No idea again. Right, what have we got? Okay, this is a tangent, and the angle between a tangent and a radius is always 90 degrees. So there's a tangent and there's a radius. So we're going to mark this in first of all. That's a right angle, that is 90 degrees. What else can we mark on then? If we know that's 90 degrees, so I'll do that in different colours so we can see I have worked this out. That is 90 degrees then. And then this angle in here, I had to work that out then. That is a triangle angle, so a triangle add up to 180. So 180 minus 90 and minus 46. So 180 to minus 90 is 90. Take away another 40 is 50. Take away 6 leaves you with 44 degrees. So that's 44 degrees. Okay, this next bit is really quite tough. This is one of the toughest things for people to see. We should know from our circle theorems, we should know the following. So let's do that again, do a better circle. So we should know this wee identity here, this wee circle theorem, which is that the angle at the centre is twice the angle at the circumference. So if you know this is x, then this is 2x. So this is actually the situation we're in here. So if you imagine if I rotated this, I'm going to do a couple of steps here to get to where I need to be. If I rotated this along, there's my centre. Okay, and if that was my y, and that was 44, then y would be half of the 44. Now it doesn't look quite like that, so we'll just change it a wee bit again. I'll do my circle again. So I've got my circle, and I'll mark on where my centre is very roughly, and you can see that's what I've got. And this is my centre of my circle. That's my centre of my circle, and that's 44. And this is actually the same as this. It's the same setup. This angle 44 at the centre is the angle at the centre to the angle at the circumference. So it's 44. The relationship between the 44 in this one down here is the same as the relationship between the 44 and the angle y in this one here. So it's just twice, 44 is twice your y. So your y is just equal to 44 divided by 2. So your y just works out to be 22 degrees. There could well be other ways of doing this, but that is the way I have gone for here today.